Okay, so today we're going to go ahead and go over notes number 4, limiting reagents or limiting reactants. Okay, so I actually had started already, but then the phone rang, so I had to stop halfway through one of my questions. But anyway, okay, back to cooking is going to be our example for limiting reagents or reactants. So if you guys remember last week, we actually talked about Grill Master Tiger's recipe for grilled cheese sandwiches. And his recipe for making grilled cheese sandwiches is that he uses 2 slices of bread and 2 slices of cheese to make one sandwich. So number 2, what happens if Grill Master receives only half of his order for that day? Well, if he only receives half of his order, then he'll only be able to make half of the sandwiches that he originally planned to make. Okay, so in this case, what is limiting the number of grilled cheese sandwiches that he can make? Well, obviously, if he only made half, or if he only received half of his order of cheese, then it would be the number of cheese that would be limiting his sandwich making. Okay, so number 4, what if the grill master received 3 times the amount of cheese that he needed? Well, if he has 3 times the amount, then he's just going to have extra cheese. Okay, because he wouldn't have enough bread to make all those sandwiches with the extra cheese. Okay, which ties into question number 5. What would be limiting him in this case? Well, again, that would be bread. Okay, the number of slices of bread that he would have. Okay, so your limiting reactant in chemistry, it's going to be the same thing. Okay, if we have nitrogen plus hydrogen yields ammonia, well, we can tell from our balanced equation that we have 1 mole of nitrogen that reacts with 3 moles of hydrogen to form 2 moles of ammonia. Okay, so what happens if you only have half of your moles of nitrogen gas? Well, remember, it takes 1 mole for this reaction to occur. But since we only have half of our hydrogen, then we're only going to see half of our reaction. Okay, and then how much hydrogen gas would you use? Well, again, if we only have half of our moles of nitrogen, then what's half of 3? That's going to be 1.5 moles of hydrogen. And then how much ammonia would we make if we only had half of this reaction? Well, half of that, 2 divided by 2 is going to be 1. Okay, so we would end up with 1 mole of ammonia. Okay, so this is going to bring us to what our limiting reactant and excess reactant is. So again, your limiting reactant is this right here. Okay, it limits or determines the amount of product that can be formed in a reaction. Okay, it's preventing us from making more. Okay, so just like in our lab from last week when we were making s'mores, well, our limiting reagent or reactant was our chocolate and our graham crackers. We were only given enough to make 4 per group, right? So again, our chocolate and our graham crackers was our limiting reagent. Our excess reagent from our s'mores lab was actually our marshmallows. You guys were given a handful of marshmallows, so that was definitely more than you needed, right? So the reactant that is not completely used up in a reaction is going to be our excess. We have too much of it, okay? So if we take a look at our example, okay, sodium chloride can be prepared by the reaction of sodium metal with chlorine gas. Suppose that 6.70 moles of sodium reacts with 3.2 moles of chlorine. What is your limiting reagent? Well, before we answer this question, you guys need to know what the steps are for solving a limiting reagent question. So, step 1. Okay, so step 1 is going to be write a balanced equation. Okay, and then after you have found your balanced equation, you're going to go ahead and solve for moles of your product for each element. To do this, convert the given for each reactant, or moles in this product, to moles of our product. If the original substances are given in grams, you'd have an extra step, converting mass to moles, but the rest of the process would be the same. Okay, and then note, if the original substance is given in grams, what do you need to do before this step? You need to convert to moles. Okay, so an important thing about step number 2, it says solve for moles of your product for each element. That is really important, because if you actually take a look at our question, it's only asking what is the limiting reagent. It's not asking for convert to grams like we normally do, or convert to liters, or convert to particles, right? It doesn't specifically tell you what to look for. So if you're given a question like what is the limiting reagent, then you're going to go ahead and solve for moles of your product for each reactant. Okay, so again, solve for moles of your product for each reactant, not for each element, but reactant. Okay, so let's go ahead and take a look at number 3. Okay, so number 3 says determine the maximum moles of product that can be made. So you're going to have 2 answers for moles of your product. Okay, and why? It's because you have to calculate, you have to solve for moles of your product for each reactant. Okay, and we usually have 2 reactants, so that's why you're going to have 2 answers. Okay, you're going to convert both reactants to moles of our product. Okay, and then which one do I use? The smaller one. The smaller of the 2 answers is the maximum product, because you only have enough reactants to make that amount. You will run out of the reactants before the larger amount is made. From this, you can figure out your limiting reagent and excess reagent. Okay, so in other words, what all that is saying is step 4. Identify your limiting and excess reactants. Okay, just by looking at your final products, so after you've converted your reactants to moles of your product, you're going to find that one of them is going to be your limiting and the other one is going to be your excess. Okay, so your limiting is going to be the smaller of the 2 amounts. Okay, and then the larger of your result is going to be your excess reactant. Okay, and then lastly, step 5 is solve your problem. Okay, so I know a lot of you might not understand what's going on yet, so let's go ahead and solve some of these sample problems. Okay, so we'll go back to that sample problem on the first page. Okay, sodium chloride can be prepared by the reaction of sodium metal with chlorine gas. Suppose that 6.7 moles of sodium reacts with 3.2 moles of chlorine. What is the limiting reagent? So remember, our first step is to write a balanced equation. Okay, so our balanced equation is going to be 2Na plus Cl2 yields 2 moles of sodium chloride. Okay, so that's going to be our balanced equation. So step 2 is going to be to solve for moles of product for each reactant. Okay, so remember, I have two givens. So because I have two givens, then that's going to mean I'm going to have two separate math calculations. Okay, so my first one, let me see, make sure you guys can see, 6.70 moles of sodium. Okay, so that's my first given. Okay, and then our second step, remember, was to convert to moles of our product. So if I'm converting from moles of sodium to moles of sodium chloride, well, how many steps is that going to be? Okay, and if we take a look at our mole map, let me just see if I have one here. Okay, so if we take a look at our mole map, okay, we're going from moles of one substance to moles of another. So because we're going from mole to moles, we only have one conversion factor, and that's going to be our coefficient ratio from our balanced equation. So our coefficient ratio, okay, if this is 1 mole of sodium, then on bottom is going to be 1 mole of sodium, and what we're looking for goes on top, which is moles of sodium chloride. Okay, our coefficients come from our balanced equation. So our coefficient for sodium is going to be the number 2, and our coefficient for sodium chloride is also 2. Okay, so we can go ahead and solve. Okay, our units are going to cancel out because moles of sodium divided by moles of sodium, they just cancel out, right? And 2 divided by 2 also cancels out because 2 divided by 2 is just 1. So what we're really left with is just 6.70. So I have 6.70 moles of sodium chloride. Okay, moles of NaCl. Okay, so that's my first given. Now I still have another given. Okay, so I have 3.20 moles of chlorine, and then again I'm going to convert that to moles of my product. So again, it's going to be moles of chlorine over moles of my product, which is NaCl. Okay, and then our coefficients, chlorine has a coefficient of 1, and then NaCl has a coefficient of 2. Okay, so moles of chlorine cancels out moles of chlorine, so I'm left with 3.2 times 2, which is 6.40 moles of NaCl. Okay, so basically what all this is telling you is that for your reactant for sodium, if you have 6.7 moles of sodium, then it's going to produce 6.7 moles of sodium chloride, which is your product. Okay, now your other reactant, you have 3.2 moles of chlorine. That's only going to give you 6.4 moles of sodium chloride. Well, which one is the smaller of the two? Which one produced a smaller product? Well, chlorine produced a smaller product. Okay, so that means this is going to be your limiting reagent right there. So 3.20 moles of chlorine is going to be your limiting reagent. Okay, so does that make sense? Hopefully it does. Let's go ahead and do another practice problem, so that way hopefully it can make a little more sense to you. Okay, so practice problem number 1, we were already given a balanced equation. So what is the limiting reagent when 80 grams of copper reacts with 25 grams of sulfur? So again, I have two givens. Okay, 80 grams of copper and 25 grams of sulfur. Okay, remember, if your question does not ask you to convert to something specific, like what is, grams of your product, well, then you are going to convert to moles of your product. Okay, so again, if it doesn't specify what to look for or what to convert to, you are going to convert to moles of your product. Okay, so let's go ahead and convert these two numbers to moles of our product. So I have 80 grams of copper. Okay, and then I'm going to convert that grams of copper to moles of my product, which is copper sulfide. Okay, so on my mole map, if I was given grams and I was asked to look for moles of my product, then that's going to be a 1-2-step equation. Okay, so my first conversion factor is going to be our molar mass from the periodic table, which equals 1 mole, and then our coefficient ratio from our balanced chemical equation. Okay, so again, our first conversion factor is going to be 1 mole equals molar mass. So if this is grams of copper, then I know that grams of copper goes on bottom, and my 1 mole of copper is going to go on top. And if you guys look at your periodic table, you'll find that your mass for copper, let me see. Your mass for copper is going to be 63.546. Okay, and then our second conversion factor is going to be our coefficient ratio. Okay, from our balanced chemical equation. So if this is 1 mole of copper, then I know that moles of copper goes on bottom, so that way my units can cancel out later. And what goes on top is what I'm looking for, which is moles of my product, which is copper sulfide. Okay, and our coefficients, copper has a coefficient of 2, and then copper 2 sulfide has a coefficient of 1. Okay, so now we can go ahead and solve. So grams of copper is going to cancel out grams of copper. Moles of copper is going to cancel out moles of copper as well. So what we're left with is 80 grams divided by 63.546, and then again divided by 2. Okay, so if you want to try the calculations on your own, you can go ahead and pause the video. Okay, but afterwards you should get the answer of 0.629 moles of copper sulfide. Okay, so that's going to be our first reactant. Our second reactant had 25 grams of sulfur. So we're going to do the same thing. We're going to convert from grams to moles of our product. Okay, so it's still going to be 2 conversion factors. Okay, so if this is grams of sulfur, then I know my molar mass for sulfur is going to go on top. And 1 mole of sulfur equals 32.066 grams. And my conversion factor from my balanced equation, so if 1 mole of sulfur is on top, then I know 1 mole of sulfur is going to go on bottom for my next conversion factor. And what I'm looking for are moles of copper sulfide. Okay, so again, our units are going to cancel out, and what we're left with is 25 divided by 32.066. Okay, and again, if you want to calculate this on your own, go ahead and pause. But the answer that you should have got is 0.780 moles of Cu2S. Okay, so again, what our calculations are saying is that if I had 80 grams of copper as my reactant, then it's going to produce 0.629 moles of my product. That's how much I'm going to be able to make. Okay, and if I had 25 grams of sulfur, my other reactant, then I'll be able to produce 0.78 moles of copper sulfide. Okay, so remember, which one is going to be our limiting reagent? Okay, which one is going to prevent us from making as much as we want? Well, our answer, remember, is always going to be the smaller of the two. So that means our 80 grams of copper is going to be our limiting reagent. Okay, because we won't be able to produce as much as sulfur can. Okay, so our next question is asking, what is the maximum number of grams copper 1 sulfide produced? Well, if we take a look at our products, well, here we can only produce 0.629 moles of our product. And here we can produce 0.780. Well, we know we can't produce that much because we don't have enough copper. So our answer, or rather our given for number 2, is going to be this right here. Okay, so 0.629 moles of copper 2 sulfide, and then it's asking for grams of copper 2 sulfide. So this is where you have to be careful, okay, because on your mole map you are only converting, okay, you are converting from moles of your given to mass of that same substance. So it's actually staying on the same side of your mole map. You're going from moles of your product to mass of your product. Okay, we're not converting from moles of one substance to moles of another substance, then to mass. We are still on the same side of your mole map. Okay, you are converting from the same substance to the same substance. So it's actually just 1. So 1 mole of copper is going to produce how many grams of our product? Okay, so the molar mass of copper 2 sulfide is 159.158 grams. Okay, so your units are going to cancel out. Moles of copper is going to cancel out moles of copper sulfide. So you're actually left with, let's see, I believe the answer your calculator is going to give you is 100.11, but remember, significant figures. Here we have 1, 2, 3 significant figures. Remember that our leading zeros are never significant. So we only have 3. So to round this correctly, we would round to 100. But remember, without a decimal, this is actually only just one significant figure. So to make our zero significant, we're going to have to add a 0 at the end, and our unit is going to be grams of copper 2 sulfide. So grams of Cu2S. Okay, so basically what this is saying is that if we had 80 grams of copper and 25 grams of sulfur, then the maximum number of product that we'll be able to make is 0.629 moles of copper 2 sulfide. Okay, but it's asking for how many grams is that? How many grams can we make? So if we can only produce 0.629 moles of copper sulfide, then we have to convert that to grams, and we'll get 100 grams of copper sulfide as our final product. Okay, and then really quickly, I did want to kind of talk to you guys about your homework. So for your homework directions, reference notes number 3 to complete the following limiting reagent word problems. find a balanced chemical equation if necessary, and follow the 4 steps. Okay, so number 1, what mass of water can be produced from 2 moles of hydrogen and 4 moles of oxygen? So of course your first step is going to be write a balanced equation since you weren't given one. Okay, so water can be produced from hydrogen and oxygen. So that means H2 plus O2 yields H2O. Okay, so to balance your equation, I have 2 hydrogens here, 2 hydrogens there. Our hydrogens are balanced. But oxygen, I have 2 here and only 1 on my product side. So that means I'm going to have to put a coefficient of 2 to make oxygen balanced. But because I put that 2 there, I now have 4 hydrogens. So to balance hydrogen, I'll go ahead and put another coefficient of 2 here. Okay, so my equation is now balanced. So now, if we take a look at our question is asking for something specific, the mass of water. It doesn't ask us to look for our limiting reagent. It's asking for the mass of water if we only have 2 moles of hydrogen and 4 moles of oxygen. Okay, so basically, again, if you have 2 givens, you are going to have 2 separate calculations. So 2.0 moles of H2 and 4.0 moles of O2. And since we're converting from moles to mass of water, if we take a look at our mole map again, okay, we're going from our given, which is grams, we're given moles. We're given moles of hydrogen and moles of oxygen, and we've been asked to look for the mass of water. So that's a whole different substance. So that means we're going to have to go from moles of hydrogen to moles of water, then to our mass of water. Okay, so that is 2 conversion factors. Our first conversion factor is going to be our coefficient ratio from our balanced equation, and then our second one is going to be our molar mass equals 1 mole. Okay, so again, first conversion is our coefficient ratio. So moles of hydrogen, we have 2 moles of hydrogen and 2 moles of H2O. That's going to be our conversion factor. Okay, and what we're looking for grams of, or the mass of water. So to find your mass of water, you're going to have to calculate, well, how much does water weigh? You have 2 hydrogens and you have 1 oxygen. So if you add that all up, you actually get 18.015 grams of water. Okay, and then solve. Now for oxygen, you're going to do the same thing. So coefficient ratio, you have 1 for oxygen, so 1 mole of oxygen, and your coefficient ratio for water, again, is 2 moles of H2O. Okay, that's our coefficient ratio. Then we're going to multiply that by our next conversion factor, which is 1 mole of H2O to molar mass of H2O, which is 18.015 grams of H2O. Okay, so again, we can solve this as well. So your units are going to cancel out. Moles of hydrogen cancels out moles of hydrogen. Moles of water cancels out moles of water. And then again, 2 divided by 2 is 1. So those are going to cancel out. Okay, moles of oxygen cancels out moles of oxygen. Moles of water cancels out moles of water. So we're left with grams of water, which is what we're trying to look for. Okay, so 2 times 18.015 And our answer is 36.03 grams of H2O. Okay, and then if we have 4 times 2 times 18.015, then we have 144.12 grams of water. Well, our question is, what's our limiting reagent, right? So which one of these is our smaller value? Well, obviously it's the 36.03 grams of water. Okay, so other words, if we had 2 moles of hydrogen, we'd be able to produce 36 grams of water. But if we had 4 molecules of oxygen, then we'd be able to produce 144.12 grams of water. Okay, so which one is going to prevent us from making as much as we want? Well, that's going to be hydrogen. Okay, so our 2 moles of hydrogen is going to be our limiting reagent. Okay, all right, so hopefully doing homework problem number 1 will help you guys figure things out. Okay, it's just like doing the s'mores. Okay, so again, if you have questions, please let us know. If you can't come to my tutorials, you can always go to a different teacher's. Okay, if you don't like the way that I explain things, maybe you can go to a different teacher also. Maybe they explain things differently. Okay, because we don't all learn the same way. Okay, so if you're having a hard time following what I'm explaining, go to a different teacher. Maybe they'll explain it a little better, and maybe they'll explain it in terms that you'll be able to understand. Okay, again, if you have any questions, let me know.